Unit 12 is about three-dimensional figures. So before we really get into things like surface area and volume, which is our end goal of this unit, we just need to make sure we understand what 3D figures are and how I'm going to refer to them. So there's two main categories of 3D figures. You have your polyhedrons and your non-polyhedrons. When I'm talking about a polyhedron, I'm talking about a solid formed by polygons. They're named by their base. Highlight this word base. That's how we name them. The two types of polyhedrons that we have is a prism and a pyramid. For prisms, these are going to be like boxes, for lack of a better word. Now, they're not necessarily just boxes because they're going to be different shapes on the bottom, but they look more like tubs or boxes than other shapes. A pyramid shape is like a pyramid. You guys can kind of see it comes to a little tip there at the end. So we have our two types of polyhedrons. Let's fill in some blanks here. A prism is a solid with two parallel and congruent bases. So if we're looking at this first polyhedron right here, it is a triangular prism because the base is a triangle. You can think of it as the top and bottom, but it may not be sitting the direction where you see that as top and bottom. But the two faces that are the same are your base. For your lateral faces, sorry, I am going all over the place with what I'm saying. A base can be any type of polygon, but the lateral faces are the faces that are not bases. These are always going to be rectangles. So if you notice in that triangular prism that I have there, you have a triangle base, and then all three sides of this are going to be rectangles. This one, we would call it, if we look at its base, the two that are parallel, this is a rectangular prism because the base is a rectangle. What would you call this one? What is that base shape? Pentagon. So we would call it a pentagonal prism. Yes. Yeah. So you slap the word that's the base and then the word prism. Now what about this one that has 6 sides? Hexagonal prism, because it's a hexagon base and a prism. The pyramid is a solid with only one base. So you notice now we only have one of those bases. It is still named by the base. So you would say like hexagonal pyramid instead of prism. The lateral faces this time are not, the lateral faces are the faces that are not bases. These are always going to be triangles. So if we were looking at these right here, again, we name it by the shape of the base. So this again is a pentagon, 5 sides, but it's a pyramid, so it's called a pentagonal pyramid. This one that has a rectangle as its base is called a rectangular pyramid. What would this one be called? Triangular pyramid. And this one is trying to tell us that that's a square, so it's a square pyramid. Or a rectangular pyramid because squares are rectangles. For non-polyhedrons, these are solids that have circular bases. So highlight that word circular, that's the difference. Polyhedrons have polygons as a base. Non-polyhedrons have circular bases. There are 3 types of non-polyhedrons. The first one is a cylinder, which is a solid with 2 circular bases. You can see it's already shaded for you, tops and bottoms. It doesn't have to be perfect like a soda can or a water bottle, like this one. It can be slanted to the side as long as it has a circular base and a circular top, it is a cylinder. A cone is a solid with 1 circular base. Again, we have our circle here, but no circle on top. It comes to a point. The lateral surface is the part of the cone not including the base. And a sphere is a solid with no base. Notice there's no bottom or top to a circle, but it is circular in nature, which makes it a non-polyhedron. Do we see the main difference between polyhedrons and non-polyhedrons? Naming them is important, but again, it has everything to do with the base of the polyhedron or the base, or like what, oh my gosh, how many bases are in a non-polyhedron? I'm sorry, I'm tripping all over my words today. I went to the Stars game last night. It went to overtime. We lost, rip, but it ended at 11:54 p.m. So I am real tired, so if I sound like a jumble, I'm so sorry. It is what it is. Let's play a Kahoot just to see if we understand how to do these. As we flip to the back, since we practiced with that Kahoot, we see that there are two more things that have to do with 3D figures. That is, again, vocabulary we need to clear up so you know what I'm talking about when we talk. A cross-section of a three-dimensional figure is the two-dimensional shape created by the intersection of a plane and a solid. So it's as if you came in with a knife and you chopped through the solid. We want to know what shape is created when you chop through it. So if I showed you this figure, this is a cube, and we have stuck a plane, like sliced through it. What shape is created by the cross section? A square. So the cross section here is called a square. If I take that same cube and I throw the plane on a diagonal through there, what shape is created by the cross section? A rectangle. And if I take that same cube and instead of doing the plane like this, if I just have a tiny little plane chopping off the side right here, what shape has been created by the cross section? A triangle. That's what a cross section is. It is the shape created by a plane slicing through a 3D figure. Now we can slice through any 3D figure. All three of these were a cube, obviously. But if I take this cylinder, that's not a cylinder, yes it is, and I chop through it with this plane, what shape has been created by the cross section? A rectangle. Which is interesting that we get a polygon out of something that's circular. Now what about number 8 right there? First of all, what is the name of the shape that we're the 3D shape? A sphere. And we take that plane and we chop it right down through. It's not telling us we're in the center, by the way. We're just chopping it down through the cube, through the sphere itself. What is this shape? Technically, yeah, I see what you're doing, but we have no indication that it's right through the center in this picture. So we're actually just going to call that some sort of oval. Because if it's off center, it's not going to be a perfect circle. It's going to be some sort of oval. Now we're back at the cube, but if I take that plane and I throw it through that cube like number 9, what is the name of the cross section? Say again? Trapezoid. Okay, number 10, let's name the shape first. Let's do like we did on the Kahoot. Is this 3D shape? Is it a polyhedron or non-polyhedron? Polyhedron. Very good. And what is the name of it? How many sides does the base have? 6. What's the name of a 6-sided polygon? Hexagon. So the whole thing would be called a hexagonal prism. Now if we take this hexagonal prism and I slice straight down into it with that plane, what shape has been created? Hexagon. Since it's straight down through it. That's our second topic today, is understanding cross sections. Now of course, we have another Kahoot to play, like we're just going right to it today. So if you would please log into this Kahoot and we'll practice and see if we understand cross sections. All right, y'all, thank you for playing. Oh, my iPad disappeared from this board and it completely disconnected. Let's try that again. The last topic when it comes to 3D figures, to again just make sure we have the correct vocabulary with each other, is called a solid of revolution. This is pretty cool, so you have to think really visually about these kinds of questions. It says, a solid of revolution is a three-dimensional figure that is formed by rotating a two-dimensional shape around an axis. The axis itself is called the axis of revolution, which makes sense since we're revolving or spinning this shape around an axis, the line in which the shape is rotated. So example, when you rotate a rectangle, around a line that contains one of the sides, so we have this line right here and we have this rectangle, and we're going to rotate it like this. When you completely rotate it all the way around the line, what shape is formed? A cylinder. So we're going to try to see if we can visualize what 3D shape is going to be created by rotating these different figures. So if you look at question number 10, we're going to take this 2D semicircle. We're going to rotate it around this axis. When we rotate it around this axis, what shape is going to appear? So we're rotating, it should be a 3D figure. A A sphere. So if we look at this, as we rotate it, we're going to end up with something that looks like this. Because it's going around and around and around and around, yes? That is a sphere. But specifically to make it really detailed for us here, we're going to say it's a sphere with a radius of what length? 7. So if eventually we're finding the volume of this revolved solid, we would know the radius of that sphere, since that's the radius of the semicircle that created it. Okay, what about this rectangle? If I take this rectangle and I rotate it around this axis, what shape is going to appear? So we're rotating, which means this side's going to be rotated around, and this side's going to be rotated around. A cylinder. Let me draw this a little bit better for you here so it makes a little bit more sense in the 3D world. So we would have this coming here, and then we'd go behind it, and then we'd have this part all the way around. It creates a cylinder. When we would find, let's say, surface area or volume of a cylinder, we would eventually need to know the radius and the height. If you were looking at this cylinder, what would be the radius of one of the bases? 4. What would be the height of the cylinder? 9. So you see this 2D image, the two-dimensional shape that we're rotating, its dimensions end up becoming part of the dimensions of your 3D rotated figure. Now last one, this guy. The line that we're rotating it around is up and down, but if we rotate it around this axis, what shape is going to appear? So I start spinning. Ooh, yeah, I heard it. We'll have something like this. What is that shape called? A cone. Now again, with a cone, eventually we're going to find surface area or volume of these shapes. We're going to need the radius and the height. What would be the radius of that cone? 2, since that's the length of the triangle on the bottom base. What about the height of the cone? 5, since that's the height of my triangle. So we're going to see a relation between these 2D shapes and their solids of revolution. But visualizing these solids is really pretty cool. So you could probably guess it. That's going to be our last Kahoot for the day, is to see if we can recognize these solids of revolutions. Now these are a little bit more challenging, so make sure you think before you answer each question in this Kahoot. Thank you guys for playing. So that brings us to the end of our notes for today. That's our introduction into Unit 12, which is about 3D solids. The rest of class, which is a good amount of time for you guys, we're going to spend working on our project. Now we don't know anything about this project yet, but I have to pass a bunch of things out to you, and then you'll have the rest of the time to start working on this project.